Atomic structure. Subatomic particles. 1. Protons are in the nucleus and have a relative charge of +1 and relative mass of 1. 2. Neutrons are in the nucleus and have a relative charge of 0 and a relative mass of 1. 3. Electrons are in the orbitals and have a relative charge of -1 and a relative mass of 1/1840. Atomic number is the number of protons, and this is the bottom number. Mass number is the number of protons and neutrons, and this is the top number. History of the atom. First, there was the discovery of an atom which was not divisible. Then there was the plum-pudding model, which contained electrons scattered in a positive charge cloud. After plum-pudding model was the nuclear model because of alpha scattering experiment, where the center was the nucleus, which had the protons and most of the mass. Electrons orbited this nucleus. Atoms passed through gold foil showed most of the mass was in the nucleus, and atoms deflected back showed that protons were in the nucleus. Finally was the Bohr model, which told us electrons orbit nucleus at specific distances, and these electrons were in energy levels. Isotopes. This is when an atom has the same number of protons and electrons, but different number of neutrons. Similar chemical properties because of same electronic configuration, and may have different physical properties because of their different masses. The time of flight mass spectrometer. This is used to find all the isotopes in element, and so can find elements. Done under vacuum, so the air particles don't ionize and register on the detector. Steps of mass spectrometer. 1. Ionisation. This happens in 2 ways. The first one is electron impact, and this is when a vaporized sample is injected at low pressure. Electron gun fires high-energy electrons at the sample to knock of an outer electron, forming positive ions with different charges. This method is used when an element has a low formula mass because it can cause larger molecules to form fragments. The second one is electrospray ionisation, and this is when the solvent is dissolved in a volatile polar solvent, and then it's injected into a fine needle to give a mist called aerosol, and the needle is attached to a high-voltage charge, so it can gain a proton from the volatile solvent. Solvent evaporates, but ion moves to negative plate. This is used for larger molecules as fragmentation doesn't happen. 2. Acceleration. Positive charged ions are accelerated by electric field to constant kinetic energy. Kinetic energy being the same means that velocity depends on mass, so lighter particles will have faster velocity and heavier particles have slower velocity. Kinetic energy is equal to half mass multiplied by velocity squared. 3. Flight tube. Positive ions with smaller mass to charge value have same kinetic energy as those with larger mass to charge value and will move faster. Heavier particles take longer to move through flight tube, and ions are distinguished by different flight times. Speed is equal to distance divided by time, and speed is also known as velocity. 4. Detection. When ions get to the detector, they make a current which is detected and sent to computer for analysis. Current is produced because an electron from the detector is transferred to the positive ion. Size of current depends on proportion abundance of the species. Mass spectrometers find mass over charge value and the abundance. And 2 electrons removed in ionization means that the mass over charge value is halved. Units for calculation. Mass is in kilograms. Kinetic energy is in joules and velocity is in meters over seconds. Calculating relative atomic mass. Relative atomic mass on periodic table is weighted average of all isotopes. Remember, if you need to give species for question, give mass number and charge. Relative atomic mass is equal to sum of mass multiplied by relative abundance divided by total relative abundance. Mass spectra for group 7s. Chlorine has 2 isotopes. One is chlorine-35, which has a percent abundance of 75, and the other is chlorine-37, which has a percent abundance of 25. So certain spectra is formed by diatomic molecules, as they can form different pairs. 160 peaks have double relative abundance, because it can be formed as bromine-79 and bromine-81 or bromine-81 and bromine-79. Used in planetary probes, so elements on other planets can be identified, and elements on other planets have different composition of isotopes. Finding M are of molecules. Using electron impact as ionization stage for a molecule means it breaks up and give a bunch of peaks because of the fragments formed. Peak with largest mass to charge value is full molecule and is equal to relative molecular mass of molecule, and this is the molecular ion peak. For electrospray ionization, no fragments form, so one peak that's equal to mass of Mh plus ion, so -1 for mass over charge value. To get M are a molecule. Electronic structure. Electrons are in energy levels suggested by 1, 2, 3, 4, and more. 1 is the closest to the nucleus, and 4 in this example is the furthest from the nucleus. This is then split into sub-energy levels, which are S, P, D, and F. S holds 2 electrons, P holds 6 electrons, D holds 10 electrons, and F holds 14 electrons. S is spherical, and P is dumbbell-shaped. In the sub-energy levels, there's orbitals, which have a max of 2 electrons in them, with opposite spin. Orbital's definition is the probability of finding an electron at any point in certain area around nucleus. Electrons fill subshells in order of increasing energy, so first 1s, then 2s, then 2p, and so on. Spin diagram. Arrows are 1 electron, and arrows point in opposite directions to show spin of electrons in orbitals, and they're in boxes, which is 1 orbital. Filling sub-levels first put the arrows in each orbital singly, then start pairing them. Remember the bus analogy. Periodic table split into S, P, D, and F block. S block is when the outermost electron with highest energy is filling the S subshell, and this definition stays the same for the P and D block. When positive ions formed, outer electron lost from outermost shell, and when negative ions form, electrons are gained. Electron structure of D block elements. Normally 4s fills before 3D subshell, so it's written in that order, but for chromium and copper only have 1 electron, is 4 subshell. And when D block elements form ions, they lose electrons from the 4s subshell first. Ionization energies. First ionization energy is enthalpy change, when 1 mole of gaseous atoms forms 1 mole of gaseous ions with single positive charge. First ionization same for each element. Second ionization energy is enthalpy change, when 1 mole of gaseous ions with single positive charge forms 1 mole of gaseous ions with double positive charge. Second ionization energy is the same for each element. Successive ionization energy tells is about the electronic configuration, as there's a huge jump in energy when electrons are removed from shell close to the nucleus. Successive ionization energy increases because when first electron is removed, positive ion is formed, and ion increases attraction on the rest of the electrons, and so energy needed to remove next electron is larger. Factors affecting ionization energy. 1. Increased nuclear charge, which is the number of protons, so more protons in nucleus means greater attraction. 2. Atomic radius, which is the distance of electrons from the nucleus. So when atom is bigger, further outer electron are from nucleus and weaker attraction to nucleus. 3. Shielding is attracted of nucleus, so electron in outer shell is repelled by electrons in complete inner shell, which weakens attraction of positive nucleus and outer negative electron. Ionization energy in periods. Repeating pattern across a period is called periodicity. First ionization gives us information about electronic structure. Helium has largest first ionization because its first electron is in first shell, which is closest to nucleus, and has no shielding effect from inner shells. Helium has bigger ionization energy than helium because it has 1 more proton. Ionization energy decreases down a group because outer electrons are found in shells further from nucleus and are more shielded, so attraction from nucleus becomes smaller. Increase in first ionization across period because electrons are being added to same shell, which has same distance from nucleus and same shielding effect. Number of protons increases, so attraction to nucleus is more. Sodium has lower ionization energy than neon because sodium has outer electron in 3 shell further from the nucleus, and so more shielded. Sodium outer electron is easier to remove and has lower ionization energy. Small drop from magnesium to aluminium ionisation energy, because aluminium starts to fill 3p subshell, whereas magnesium has its outer electron in 3 subshell, and electrons in 3p subshell are easier to remove because 3p electrons are higher in energy and are shielded by 3's electrons. Small drop in ionization energy from phosphorus to sulfur, because sulfur has 4 electrons in 3p and 4th electron is paired with 1st electron in 3p subshell. When 2nd electron is added to 3p orbital, there is repulsion between the 2 negative charge electrons, which makes 2nd electron easy to remove. Patterns in 2nd ionization energy. 2nd ionization plotted shows all elements shift to left similar to 1st. Group elements are peaks of graph. Lithium has larger 2nd ionization energy than helium, as it has more protons.